section, which is this one here. We're going to be looking at sampling, and this is the introduction, chapter 5, and then next week we'll do the rest of chapter 5. Not really much in the way of calculations until we get to the end of this section. Most of it is going to be introducing you to the idea of one of the fundamental things that you do in statistics is you collect information, right? You collect data. We very often do that in the form of a sample. So we're going to introduce you to some of the terminology that is used: populations and samples and census. So a population would be everybody that you're interested in finding out about. So everyone you are interested in finding out about. Finding out some, what would I call it? Some feature of them. So for instance, if I was interested in the average age of Americans, then the population would be all Americans, right? Because I'm interested in their average age. If I was interested in the average height of Olympic college students, the population there would be students at Olympic College. And what I'm interested in, well, I'm interested in their height. So the feature in that case would be height. If I was doing the one about the population, the average age, say, of Americans, in that case, the population, as I said, would be all Americans, and the feature that I would be interested in is their age. A sample is a small group of people, people or data, depends on what you're collecting, a small group of people from the population. So I'm interested in the average height of OC students, right? OC students are going to OC right now. I guess I could get every single one of you and get a tape measure and measure all your heights, or at least ask you what your height was and hope you didn't lie to me. But can you imagine that would be very time consuming, quite expensive on time, if nothing else. And I don't want to do it that way because it's just not practical. Well, what I could do is, couldn't I just find 20 of you and measure your heights? And let's say your average height is 5'10". Then I could say, with a reasonable degree of confidence, that the average height of OC students will probably be close to 5'10". Right? I'm not saying it is 5'10", but wouldn't it give me a kind of ballpark figure that would be reasonable? And so the idea of a sample is that you only ask a small group of people from the entire population, but you base your conclusion on the fact that you hope that your answer that you got from the sample should be very close to the real answer you're interested in, right? I'm interested in the average height of all OC students, but I got this small group and they were 5'10". So I'm figuring out it's probably close to 5'10", right? Now you can imagine there's a lot of details to picking a good sample, right? So you can give that good conclusion. When you make an inference about a population from a sample, you're assuming that the sample is a fair representation of the population, right? Would you agree it would not be a good idea if the 20 people I picked, because I'm lazy, is I went over to the PE and the basketball team was training and I used all their heights? Would you agree that basketball players are not a typical representation of all the students that go to OC? That would be a bad sample, wouldn't it? It's not a fair representation of the population, right? So I want to find smaller students and taller students and everything in between, right? And I want to get a pretty fair representation of, males and females as well, right? Because males tend to be a few inches taller than females in general, right? So that is an important feature, that when you pick a sample, you want it to be a fair representation of the population. Otherwise, you can't make an inference. You can't say, well, it was 5'10", so I'm pretty sure the real answer is 5'10". There is sometimes, I wouldn't even call it a sample, but you can collect a group of people, and if you take a census, what you do here is you actually do ask everyone in the population. So a census would be, I did actually find every single person in OC and I measured their height. Census can be done sometimes. The main reason that you can get away with it would be if the population is relatively small, right? Let me put you on the spot here. Isabella, if you want to, do you want to share the name of that place you work in again?
Miracle Ranch.
Right, so Isabella works in Miracle Ranch. Suppose I wanted to find the average height of people who work in her building, right? I'm making this number up. There's only 12 of you. Would you agree I could do a census? There are only 12 of you, I could do it. In which case, wouldn't the answer I get be perfect? That is the average height of people who work in your place. Right. Now, if you had said, oh, I don't know, I work in Costco, right, that could be 400 people. And I'm going to say, nah, too many. In that situation, wouldn't I probably do a sample rather than a census? Right. And if it was OC students, I'm definitely doing a sample, not a census. And if it was the population of the world, nobody is doing a census, right? So you've got this kind of balance. Should I try a census? Yes, if it's feasible and doable. It's always better to do a census because isn't that you got everybody and you know the answer. On the other hand, that's probably not going to be the case in most situations, so you do a sample. So now we're going to look at these things called bias. Oops, bias. Bias in a sample. Yeah, we know the word bias. Do you know if someone says I'm biased, right? My political views are biased, which would mean I'm more in favor of Conservative or I'm more in favor of Democrat or whatever, you know, I'm biased. I'm biased in favor of Scotland. I think Scotland is the best place in the world. America's a very good second, but Scotland's first. Most of you will probably think that America is first, right? You have a bias. We all have biases. Doesn't mean we're bad people. It's just how we are. Well, bias in samples is a bad thing if you want to get the truth, right? If you want to get the real answer. So bias in a sample occurs when the information that you get from your sample does not represent the population as a whole in some significant way. So let's suppose I'm doing the OC, I'm picking 40 students and I'm getting their height, right? If I pick basketball players, wouldn't that be biased because I'm picking taller people than the typical group, right? That would be one form of bias. Suppose I only, because I felt like it, only measured the height of blonde people, right? Don't know why, I just said, I'm only picking blonde people. In a way, it's a bias, aren't I, picking blonde people? But it's not a significant bias. I'm making an assumption. Do you think blonde people are any taller or shorter than brown-haired people or red-haired people? I don't think there's probably any significant difference there. Because you see how that's an insignificant bias, right? It won't really affect the outcome. Whereas height certainly would, right? You know, I think that would be a significant distortion. But there are many, many kinds of bias. We're only going to deal with 3 of them in this section. And then there's about, well, off the top of my head, there's another 4 to come after that. So here are 3 examples of bias, and I'm going to talk about each one in turn. We'll start with what is called non-participation bias. Right. This happens when a substantial number of people in your sample either refuse to answer or don't take part in your survey. Now, let's give you some examples of non-participation bias. Let's suppose I'm interested in the political views, who you're going to vote for in the next, whatever's coming, the next election, right? And I get a list of 100 people to be in my sample. And I find these people and I say to them, can you tell me who you're going to vote for? And 99 of them answer your question. And one of them says it's none of your business. That one person is an example of non-participation. But since I asked 100 people and only one of them said no, it's not going to make a heck of a difference. Agreed to the answer, right? So if 82% are going to vote royalist, you know it's going to be fine, right? On the other hand, suppose 15 of them said, I'm not telling you, I don't want to tell you, I'm not interested in telling you my political beliefs. Isn't 15 out of 100 people a lot of non-participation? And just for argument's sake, can you imagine that you were doing it and a lot of people didn't want to tell you because they were Trump supporters, right? I'm not telling you. I don't want to tell you I'm a Trump supporter, but I'm not. You don't know that. I'm not telling you, right? Well, if 15 out of 100 don't tell you, couldn't there be 15% more people going to vote Conservative than there would be voting Liberal? But you wouldn't know it because in your sample, you know, you would say, well, from the people who answered my question, 40% are going to be this and 60% are going to be that. But couldn't that data be totally switched on its head? Non-participation. You ask them the question and they don't participate. A different way of getting non-participation can be like you're watching a TV program and the guy says, hey, phone this number, dial 1 if you're in favor of abortion, dial 2 if you're against abortion, right? That kind of thing. And people are watching the TV. Don't some of them phone up and some of them don't? Well, the ones who didn't phone up, aren't they not participating in the sample? That's another example of non-participation. It's not that you got to ask them the question and they said, I'm not telling you. In that second version, don't you not even know how many of them didn't phone you? Because they didn't phone you, right? It could be 2 people, it could be 2,000 people, right? That makes your data dodgy. You agree? You can never be quite sure how good the data is because of non-participation, right? Comfortable with that idea? So we'll move on to selection bias. This happens when your sample is chosen in such a way that it is not a fair representation, right? It is not a fair representation of the population. We've already done quite a few of them. Let's just regurgitate a few. If I'm interested in OC, height of OC students, and I, being in charge of it, went and picked the basketball players, wouldn't that be an example of selection bias? The people I selected aren't a fair representation of OC students, right? They're taller than most. Another example of selection bias. Suppose I'm interested in who you're going to vote for in the next election, right? And I decide that I'm going to ask people on Wednesday at 1 o'clock in the mall. So that's where I'm going to get my sample from, right? People that pass me by in the mall at 1 o'clock on a Wednesday. Now, why that is a selection bias? Well, you tell me, what is wrong with that sample? I'll tell you what I think is wrong with it, but what do you think is wrong with only asking people who are in the mall at 1 p.m. on a Wednesday?
Because of the working people are actually going to be at work instead of browsing through the mall.
Right, you see, I'll never get to talk to any of them, will I? And couldn't they be different political views than the people who are not? Right? The people in the mall would be probably retired people, right? They don't have a job anymore. And they tend to vote one way around the other, right? More one way than the other. Couldn't it be very young people, right, who don't have a job or, you know, work weird hours, but they could vote differently again? See, that is an example of a selection bias. So if your sample is in some way not a fair representation of what the population looks like, that is a selection bias problem. How else could I do that? Suppose you were interested in people's view about owning guns, right? Are you in favor of people owning guns? Are you against? I can't remember which amendment is it. Is it second, third, fifth? What number is it? Tell me, guys.
Second.
Second, right. So are you in favor of the Second Amendment or are you against it? That kind of question. Suppose I decided to ask people outside a gun shop, right, as they come in and out. Would you agree I'm probably going to get a different answer than if I was outside Toys R Us or something, right? Selection bias is a big problem. If you don't pick a good sample, right, the people are a fair representation of the population, any information you get from those people can very often be tainted, right? By that I mean, you come to a conclusion that might not be realistic. You see that could happen, right? Now, not all selection bias is bad, right? Sometimes you might, for whatever reason, get a slightly different group of people, but as long as the thing that made them in your sample not significant. Example, suppose, back to blonde hair, suppose I decide red hair. Suppose I only ask red-haired people how they're going to vote. Do you think the colour of your hair is going to have any strong influence on your political views? I doubt it, right? I don't think that would be a problem, right? Okay, my selection bias is I didn't get people with different coloured hair, but it wasn't something that was important, right? So yeah, you can have some bias, but as long as it doesn't really affect what you're asking, you're okay, right? So I don't think people's hair color matters. Do you think it would matter if I only asked women what their political views were? So my sample only had women. Do you think that would be a selection bias that would be important?
I feel like it wouldn't matter unless like that you had a woman running against a man, and then it would be very biased.
Interesting. Not contradicting what you say, Maggie, but the data out there is, do you know that women tend to vote differently than men? Not a lot, it's like a couple of percent. If you're interested, women tend to vote Democrat a couple of percent more than men, right? Men tend to vote a little bit more Republican, a little bit less Democrat. Women tend to vote a little bit more Democrat than men. So you'll get women who vote Republican and men who vote Democrat, right? It's not clear cut, but there is a wiggle room. So if you only ask women, you are going to get a slightly different result than if you asked a mixture of men and women. So it would affect them in that case. I think I'm out. Can anybody think of just off the top of their head, doing a survey that would have selection bias in it? Think of a question to ask people and then tell me what kind of sample you would get that would show selection bias. Can you think of an example?
Yeah, I have one.
Go for it.
Okay, you want to get the average height of the basketball team, but you only measure the starters instead of the whole team, right? Or no?
Oh, but I don't know enough about basketball. Are the starters the taller guys?
No, they're just the first people who play.
Oh, okay. So there might be some small people in there, but the people that get to be in the team are the tall ones. Okay.
But there's like probably 20 people on a team, but the starters are like, I don't know how many people on a basketball court at a time, but.
Okay. Any others? I wish I knew more about basketball to understand that one, but that's fine. That's my problem, not yours. Okay, let's try our third one, response bias. Again, we've talked a little bit about this. Now, in this here, there are different nuances to response. So I'm not quite sure what the sentence is, so I'll just verbalize it instead. That way it gives me a chance to do it. By giving you examples of response bias. Some people are influenced, right? Or the response to a question is influenced in a variety of ways. Here's one example. Suppose you were collecting a social, for a social scientist, what males looked at when they were trying to pick a girlfriend, right? So it's one of those magazine ones, right? If you were asking a guy and the person who was asking the question was a guy, and they went and said to you, what's the most important thing about a girlfriend? And you would say looks, personality, sense of humor, right? You give them like 5 choices, right? If a guy asks a guy, would it seem reasonable that you'd probably get a more honest response from them than if a girl was asking them? So instead of him saying, oh, it's their looks, right? If they're good looking, right? That's the first thing I go for. They might say, oh, it's their personality, because don't people want to be considered nice people? And being good looking is very superficial, right? And you know what the person's like as a person is a little bit more deep. And maybe he likes the girl, right? You don't want to say the wrong thing there either, right? So in that case, was it the response bias caused by the person who was asking the question, right? A woman asking the question might get a different response from a guy than the guy asking the question. Now, I'm doing it from a guy's perspective. Would that work the other way around? If a woman was asking a girl that question, would they change what they decided was the first thing or not? I don't know enough about women and the way their brains work, so I'm definitely not going there. But there's at least a possibility of response bias, right? Another example of response bias. If you ask someone a very sensitive question, the response that you get may not be true, right? If I went and conducted a survey on high school students, and the question I was asking them, have you taken any of the following, and then you read them out, illegal drugs in the last week? Can you imagine that the response I would get would be less than honest in many situations? People do not like to tell the truth in a situation that involves delicate, sexual relationships, drug taking, illegal activity, you name it, anything that's very sensitive to a person, and they don't want to look bad, right? Again, that's another emphasis thing. And it's very difficult to get good data when there is a biasness in the response, right? The answer may not be correct, either because it's so sensitive or they don't want to admit they're committing a crime or have committed a crime, that type of thing, right? And so response bias is difficult to overcome. So I'm going to go back to the three guys here and tell you some of the ways you can try and remediate it or reduce it. Right, non-participation bias. You can sometimes get around it by simply providing financial reasons to do it. Have you ever been sent an email where they'll promise you $5 or $10 if you fill it in? I actually get letters every year. I don't know why they like me, but they send me $1 and then I have to fill in a survey online. And since I've already got the dollar, I feel guilty if I don't fill in the survey, right? So can you see that that would reduce the non-participation, right? That's one way of alleviating it. They have other ways. Sometimes they explain to you why they're collecting the information and that nobody's going to be a follow-up, right? Like, well, once I find out you're a Democrat, can I get your name and address? Because I'm then going to send you, can you give us money, right? You know, I don't know who you are. I'm never going to find out who you are. You can certainly be careful about selection bias. Can't you just make sure that when you pick a sample, it's a fair representation of what the population looks like, right? So don't just pick basketball players, or don't just pick females, or don't, you know, whatever it is, don't pick people outside a gun shop if the question is about guns, right? All those kind of things. You can avoid that. Response bias is one of the hardest ones to remediate against, but it can be done. So suppose we were doing the one about teenagers and drug use. One way you could do it is take each high school student individually, take them into an office and give them the piece of paper where they write down their answer, have a box with a slit, and then say to them, look, your name is not on this piece of paper. Once you fill it in and fold it up and stick it in that box, give it a good shuffle, I won't know what one you did. It's safe. Well, the reason we want to know it is because, you know, we want to know what kind of illegal drugs high school students are taking, because it allows us to know what we should be looking for an overdose. So if a student goes out with an overdose and we know that the drug of choice right now is drug X, then they've got a good idea when the medical people comes, okay, this guy's probably overdosed on X, that's the most likely thing. We, you know, antidote, we might save their lives, right? Whatever it might be, this is the reasoning we're getting it. So you take away that fear of telling the truth. Can you see that you might get good data out of that now, that you've kind of arranged it in such a way that it is anonymous and there's a good reason for you to tell me what you know, right? And that's how you get around those situations. Are we good? So there is a lot. Can you see how much nuances there are in a simple thing like just asking people questions? Right, collecting a sample. Now, the last thing I want to get done, and then we'll look at the homework questions, is the only one of the lot that actually has some numbers. And it's called the conservative margin of error. So what you're going to do in number 4 is this conservative margin of error, by the way, only works on questions that have a yes, no to them, and that you end up with a percentage. So the kind of questions I could ask you, like, are you married? Yes, I am, or no, I'm not, right? So you get a sample of 400 people and you find out what percentage are married, right? So when you're finished, your sample is 42% of them said, yes, I'm married. Or 14% said they'd been to the cinema last week. 40% say they hate Pepsi, Coke, whatever, right? 10% are in favor of abortion. Whatever it is, it's a percentage at the end, right? The guy called the conservative margin of error is a number that we've kind of done through experience that gives us an idea how much wiggle room there is in your sample. In other words, if you do a sample and 20% of them say, I went to the movies last week, now, and we'll assume they're not lying and everything else was good, you know that's not guaranteed to be the real answer for everybody in America, right? But wouldn't it be pretty close? 20%, give or take, 4%, or give or take 9%. You know that give or take bit? That's what the margin of error is. The conservative margin of error is the wiggle room that you've got in it. And you get it by 1 over the square root of n. And n is the sample size. So let's suppose I ask people, right, have you been to the cinema in the last week, right? And my sample ended up being 250 people. And it was a good random sample, right? Old and young and everything else that you could think of. It was a good sample. And I'm pretty sure that most people said an answer that was true. And I got that the percentage of people who said yes, and you read that guy out as P hat. You've seen the little hat guy, we use them in other places. And the percentage who said yes was 21%. I'm just writing that as a decimal, right? The conservative margin of error, CMO, is 1 over the square root of n. So that ends up being 1 divided by the square root of 250. And the answer you get is 0.06. Can I just round it to 2 decimal places? Or as a percentage, 6%. So if someone was saying to me, what's your prediction on everybody in America? What percentage of all Americans have been to the cinema in the last week? You would say 21%, right? My P hat, give or take my conservative margin of error. So it would be give or take 6%. So the real answer could be as low as 15%, and it could be as high as 27%. But don't you get a kind of ballpark figure of where the real answer is now? Right? 21%, give or take 6%. That's quite a wide margin, but at least you know something, right? Now, let's just pretend that it wasn't 250, but I got a lot of money. And it was 25,000 people I asked. And just to make the numbers the same, it was still 21% of them. Would you feel more comfortable about that 21% being nearer to reality because you asked a lot more people? Would that seem reasonable? If you asked a lot of people, you're probably more accurate than if you only asked 250. Well, the conservative margin of error reflects that. It's 1 over the square root of the sample size, 1 over that number, which should be a really tiny decimal. I hope 1 divided by the square root of 25, 1, 2, 3,000. And we get 0.006 or 0.6%. So if I was going to estimate what percentage of all Americans had been to the cinema, it's P hat plus or minus the margin, conservative margin of error. So it would be 21%, give or take 0.6%. So it might be as small as 20.4 and as big as 21.6. Now, do you see that that is a very narrow window on where I believe the true answer lies, right? Over here, isn't that, well, there's a lot of places the right answer could be, right? It could be as low as 15, could be as big as 27. In this case, it's, 20 and a bit, 21 and a bit, much closer. And I think that reflects reality. Would you agree? If you ask 250 people, you're not going to get as good a result or as accurate a result as you ask this. It might surprise you to see how close you can narrow in reality. Because, I mean, America's got 300 odd million people, yet I can come up with this answer. Now, we're assuming that my sample was a fair representative sample, right? All the other things that could go wrong, we're comfortable that we've cured that. That is the power of samples. It allows you to find things in a reasonably practical way. I know 25,000 is overkill, but you can certainly ask 250, couldn't you? Right? That's not unreasonable. Any questions before we look at what the homework questions look like? Because that's kind of where I'm. Just so, have you ever heard on TV, politics are the key place I hear these things, where they say, oh, the latest poll. You know, poll is just another word for sample, right? So the latest poll is that in Kansas, the Democrats are 42% with a margin of error of 3%. You heard those kind of numbers? 42% plus or minus 3. Can you kind of see where that number came from then? The margin of error. Theirs is slightly different, but it's pretty close to what we just did. Theirs is a little bit more sophisticated, but it's the same idea. Right. For what time? Oh, somebody in the chat. Someone has just told me that Joe Biden is in Seattle.
Yep.
My question is, how does he know?
It's on the news.
That was a joke.
Oh.
How does he know? No more political jokes from me. Let's move on. You got that joke, Isabella, didn't you? Okay, at least one of you got what I was nattering on about. Okay, here we go. Oh, darn it in space. There we go. I'll try to make this bigger. I'm not sure I'm succeeding. Okay. Oh. There, make that bigger. Okay, that's pretty good. Just because I don't know what kind of screens, it might help if you can actually read it, right? Because they're quite small. According to the fundamental rule for using data for inference, which basically means make sure that your sample is a fair representation of the population. That's what that rule is. When can you make an inference about the larger group? And it's that one. The data, right, the things you collect, should be a representative, a fair representation of the group. Now, here are two stories. In each case, briefly discuss whether you think that the sample that they used should be used to make an inference about the larger population. So should I use this sample to predict what the population is? God, it sounds like that Roy wrote this one. You're interested in heights of women in a psychology class, and you used them to do the average height of all women at a college. Do you think only measuring the height of people who take psychology? I know that's not the same as all the women in the college, but do you think it's going to matter? Do you think taking psychology makes you taller or smaller than the rest of them? So you've got yeses and nos, pick the one you like. Parents of children attending a daycare facility are surveyed about whether the state government should increase funding for state care or for daycare providers. I'm stopping there. If you only ask people with a vested interest in yes, you will not be too surprised when the sample you get is not a fair representation of the population. Would you agree a lot of these people are going to say, yes, we need more money for daycare. I'm sending my kid to daycare. I would like it to cost me less, right? That would make sense. Would you agree it wouldn't be a good idea to tell people in jails, do you think we should reduce the sentencing in jails? I'm being silly here, right? But you can imagine that's not a good sample. right? Those people have got their own biases, right? Okay, a political scientist surveys 500 voters, randomly selected from a list of all the registered voters. And the purpose is to estimate what percentage are going to just vote. They don't care how you're going to vote. They just want to know, are you really going to vote, right? Now, the population of interest here is everybody that you're interested. So all registered voters in the community. Wouldn't that be your population? And the sample, well, 500 people randomly selected. Wouldn't that be where your sample came from? Right. Now let's jump ahead to some of the bias questions here. Here we go. In each of the following situations, indicate whether there's a potential bias, and is it a selection bias, a non-response bias? Oh, I didn't do a response bias. I guess I should. Do you know if you have a TV program and people were asked, do you turn up or not? No. People were asked, are you in favor of abortion? And people choose to respond. Respond and non-respond are the same big group, right? Those who ask the question are the responders, right? And those who don't ask, answer the question are the non-responders, right? So a survey question was asked of unmarried men. What is the most important feature you consider when you want to date someone? The results were found to depend on whether, there's a nice story about the men and women thing. Would you agree that in that case, the response bias is the one that caused it? People respond differently depending on who's asking them in that particular one.
So how
Yes.
can I write that down for a response bias? The answer depends on who the interviewer is?
No, you just pick the word response bias. They give you 3 choices. You tell me which one that is. And that was an example of a response bias.
Write it down on my note.
Are we good? You kind of broke up there.
I'm trying to write it down on my notes.
Oh, a response bias. We've got that in one of my earlier notes, actually, didn't I? Yeah. It's number 3. I couldn't find a nice way to say it in English, so I left it blank, but I told you stories instead. So response bias would be when the answer can be... You finished? I don't want to talk over you. Okay.
It seems like a response bias depends on who the question is asked by, because it could be different if a male interviewer or a female interviewer.
Right, that is an example of a response bias, but a bigger description of a response bias would be when the response can be different depending on the circumstances. How about that as a vague one, right? The circumstances could be the person asking you, and could also be on the question that's being asked. People don't want to answer questions that make other people think that they're not nice, right? If I went and did a survey on, have you ever beaten your wife, right, amongst married men, right? I doubt if I'd get the truth. Would you agree that a lot of people would not say, yes, I have? Right, that would be an example of a response bias, where people don't respond accurately for various reasons. Now, a telephone survey of 540 residencies is conducted, and 150 of them said, I'm not telling you. Wouldn't that be an example of a non-response bias? When people don't answer your question, it's non-response. A response bias is more connected to the answer they give might not be the truth for various reasons, right? How about randomly? A representative sample is chosen, but a subset of the sample cannot be contacted or does not respond.
Non-response.
Yeah, just a non-response. I mean, the reason they didn't respond was, you try to contact them, but they never picked up the phone or answered the mail or whatever it was. The middle one. A magazine sends a survey to a random sample of people who subscribers to their magazine, and they ask them whether they would like the frequency of the publication to be reduced from twice a month, bi-weekly, to monthly. Right. So do you want it to be once a month now, or do you want twice a month? I guess you could say response bias. People would say bi-weekly so that they don't hurt the publisher's feeling. I'm not convinced by that. I mean, if you went and said to me, I get a magazine, and you said to me, we can send you out two publications a month, or we'll just send you one a month. Oh, but if we send you one a month, you only need to pay half as much money, right? Because you're only getting half the things. Can you see that might be a different answer than if, oh no, you're only going to send it once a month, but you still pay $50 a year, right? So you can look at that. Oops, something bad happened. Can you still see the thing? Oh, my screen went black, but it went back, so I'm not worried. Ah, perfect timing. Here is our conservative margin of error question. There was a random sample of 557 adults in America, and they asked, when a person has a disease that cannot be cured by a doctor, should they be allowed by law to end the patient's life by painless means? That's called euthanasia, I believe. If the patient, and that's them going on, if the patient asks for it. Of those sampled, 71% said yes. Fair enough. Calculate the conservative margin of error. Now, can you remember the formula? 1 over what? Conservative.
Square root.
Okay,
Square
so
root of the
square
number.
root and square root of 557. I'm just putting in the calculation for all you would put in is what that is. And they want the answer as a percentage. So here goes. 1 divided by square root of 557. And the number I've got is this guy here. It's 0.0423 and a lot of other digits, right? Now, that's not the correct answer because they want a percent, which you can see here. Now, if I turn that into a percent, you simply just multiply it by 100 and you get that. Not that, you get that, right? Now, when they said here, round off the answer to 2 decimal places, I'm not 100% sure I know what they mean. Did they mean the original decimal rounded off? If they did, then won't the answer be 0.04, which is equals 4%, right? Or do they mean that guy gets rounded off to 2 decimal places, in which case they mean that, don't they? Those are good at interpreting English. Do you think it's 4% or 4.24%? Which do you think they wanted us to do? Because I'm not sure.
4.24.
Okay. Now, suppose I do that and they say it's wrong. Won't I fix it by saying 4%? So it's not like the end of the world. So let's say it's 4% because I want my life to be easy. Now, 71% answered yes. Compute an approximately 95% confidence interval. Do you see when you take the answer plus or minus a margin of error? That interval that I got, in the question we did, that is a 95% confidence interval. What that means is we're 95% sure the real answer is in that interval. So I'm going to do 77 take away 4, which I believe is 67%. 71, I should say, take away 4. And 71 add 4, which is 75%. And that would be the answer. Are we comfortable with that? You're probably, because, statistics isn't like math. In math, you solve an equation, there's only one answer and everybody agrees on it. You're probably going to have some disagreement with some of the earlier questions, you know, the ones where they give you 4 choices and you think it's 3 and somebody thinks it's 2. If they make it wrong, you can always, you know, re-guess, and then once you see what their answer is, you might disagree with them. I've disagreed occasionally as well. You know, sometimes I think, nah, I like the 3rd one better than the 4th one. You know, it's a judgment call. So don't freak out too much if that happens, because I wouldn't be surprised if it did. And last name and